In this video, we will teach you the standard form, center, foci, and vertices of ellipses by JT and Dylan. So first with the equation, you will need to rewrite it so the x and y values are together. So you will get 16x squared minus 96x plus 25y squared minus 200y equals negative 144. Next, you'll have to factor out the x and y coefficients. So for x, you'll factor out a 16, and for y, you'll factor out a 25. So you'll get 16 times quantity x squared minus 6x and 25 times quantity y squared minus 8y equals negative 144. Now you'll have to complete the square. For x, to find this value, which is c, you take the negative 6, the b, and divide it by 2 and square it. Negative 6 divided by 2 is negative 3, and negative 3 squared is 9, so you add 9. You do the same for this side as well, but you take negative 8 and you divide it in half, and you get negative 4, and negative 4 squared is 16, so you add 16. Now that you have gotten the c values for each of them, you need to take them and multiply them by the coefficient. So you take 9 and multiply it by 16, so 9 times 16, and that equals 144. And then you take 16 and multiply it by 25. You take 25 times 16. That equals 400. So you take these two values and you add them to the other side. So you get plus 144 plus 400. After simplifying, you can take the 16x squared minus 6x plus 9 and simplify it to 16 times quantity x minus 3 squared. And then you can do the same for this side. You get 25 times quantity y minus 4 squared. And then if you solve this side, negative 144 plus 144 is 0, plus 400 is 400. Finally, to find the standard form, you need to divide both sides of the equation by 400. So you divide this side, 400. You divide this side by 400. So you can get this side to equal 1 like in the standard form equation above. And so after you do that, you will get x minus 3 squared over 25 plus y minus 4 squared over 16 equals 1. And that is your standard form of the equation. Now that we know the example standard form, we can find the center, foci, and vertices of the ellipse. To find the center, you use HK, which is 3 and 4. So the center is at 3, 4. Now to find the foci, we use the equation a squared minus c squared equals b squared. And we already know the a squared and b squared from the equation up here, so we can plug them in. And so we get 25 minus c squared equals, and b squared is 16, so we have 16. And so we subtract 25 from both sides, leaving us with negative c squared equals negative 9. And then we divide both sides by negative 1. And we get c squared equals 9. And so c equals the square root of 9, or plus or minus 3. And now that we know c, we can use that to find the foci. Now that we know the value of c, we can use that to find the foci points. The foci points are h, k plus c, and h, k minus c. So if we plug h, k, and c into both of these, we can find the foci points. So we get 3, 4 plus 3, and 3, 4 minus 3. So we get 3, 7, and 3, 1. These are our foci points. Vertices, you use points h minus the square root of a squared k and h plus the square root of a squared k. Since we already know the values of h, a squared, and k, we can find the points. So we know that h is 3, so we get 3 minus the square root of a squared is the square root of 25. And the square root of 25 is 5. 3 minus 5, k, and we know k is 4. And then for this one, we know 3 plus 5, 4. So we get the points, we get the points negative 2, 4, and 8, 4. So those are the vertices. To find the co-vertices, we can use the points h, k minus the square root of b squared and h, k plus the square root of b squared. Since we already know h, k, and b squared, we can plug them in. We know h is 3. There we go. We know k is 4. And we know b squared is 16, and the square root of 16 is 4. So we get 3, 4 minus 4. And then we also have 3, 4 plus 4. And so these end up being 3, 0, and 3, 8. And those are the co-vertices. Now that we know the center, foci, vertices, and co-vertices of the ellipse, we can graph it on a coordinate plane. Let's start by graphing the center point at 3, 4. Then we can graph the foci at 3, 7, and 3, 1. And then we can graph the vertices at negative 2, 4, and 8, 4. And then the co-vertices are at 3, 0, and 3, 8. Now, if we connect the vertices, we can form what our ellipse looks like. So that is the basic shape of the ellipse of this equation. Thanks for watching. Hope you learned how to find the standard form, center, foci, and vertices of an ellipse.